Did it look like this? Okay. Okay, so exponential, right? How do you solve an exponential? Get the power by itself and then write it as a log, okay? This is the whole power. Alright, so what are we going to do first? Add 4. Alright, so now it looks like this. Now what are we going to do? We can either leave it as 15 halves or you can write it as 7.5. I wouldn't write it as a decimal if you had to round it off. Okay, so I'm just going to go ahead and practice some good stuff here. I'm going to leave it as a fraction. Now let's write it as a log. It's going to be log base of, very good, is equal to, okay, y'all, this right here, it's just a number. That's all it is. It's just a number. Now, I very nicely fixed all your calculators except for the one that has the big slash through it on the board over there. Alright? 2742. At first I thought it was just me, but it wasn't just me. I worked, and then I thought maybe it's the calculator. And then Thomas looked at it and he said, yes, someone had messed up the port where you plug it in, where I plug the cable in the top. And so it won't transmit. I can't transmit the new operating systems to it. So that calculator will not go math, alpha, math. You can't use it to change base. Okay? But all the other calculators you can. Alright, so here's what I would do on my calculator. I'd go math, alpha, math, and I'd put a base of 3, and then I'd put 15 halves in that other square. Does everybody know where I am? Okay, now what am I going to do? I got to solve for t. What am I going to do with what you have? I'm going to add 5 to it. Okay? So then I'm going to add 5. And then what am I going to do? Divide by 2. Okay? What I don't want to do is I don't want to round stuff off and then keep rounding it off, because that's going to skew your answer a little bit. Alright? So t is equal to, what'd y'all get? It's 3 decimal places. 3.417. Perfect. Okay? 3.417. That's approximate. It's rounded off. Alright, anybody got a question? Okay. So let's do, I want to work 2 more. Okay? And then I want to do what we were doing today. So here's the first one. Now this one's going to be kind of difficult. Some kids will have a hard time seeing this. But, hey, y'all remember when you factored stuff like this? Remember when you factored stuff like this? How did you know if this thing would factor like this? If this exponent was what? Half of that exponent right there. And then this actually is what it would factor into, right? Because it would factor into x to the third times x to the third. What is x to the third times x to the third? X to the 6. Okay, a minus sign at the end means one's a plus and one's a minus. The factors of 12 that subtract to be 4, 6, and 2. Alright? So, you remember when we did that? This is going to be the same kind of thing, but it's going to look weird and crazy. Why? Because I'm going to have x's as in my exponent. Alright? So, here we go. You ready? E to the 2x minus 3e to the x plus 2 equals 0. Yeah. Y'all, this is a quadratic. Okay? This is just like a quadratic. And the only way to solve it, you can't collect these. okay? Because they're not like terms. This is e to the 2x, this is e to the 1x. So the only way to do it is to factor it. Is this guy half of this guy? Then he factors. So e to the 2x factors into what? E to the x times e to the x. Very good. What's a plus sign mean? They're the same, and they're the same as the first one. So minus and minus. The factors of 2 that add to be 3. 1 and 2. Okay? Now, what do I do with each one of those factors? Yeah, you set it equal to 0. It looks like e to the x minus 1 equals 0. So e to the x is equal to 1. Over here, you got e to the x minus 2 equals 0. So e to the x is equal to 2. Now, what am I going to do with them? There you go, y'all. This is rewrite that thing as a log. ln of what? 1 is equal to x. ln of the answer is equal to the exponent. Base, answer, exponent. That's the way it always is, guys, okay? Over here, what's it going to be? ln of 2 is equal to x.
How do you not use ln?
Because e is my base. Anytime e is your base, now look, this is what I just asked the other class, okay? Say that you get to a test and you just, I don't know, you're just working your problems and you're just trying to work them and get them all right. And you go log base e. Will you be okay? Yeah, you'll be okay. All right? You'll be okay. All right, over here, what's x equal to? What is ln of 2? Point what? It's 0? ln of 1. Yeah, sorry. What did I say? Oh, sorry. This one's 0. All right. And this one, the x is? Very good. Now, look. Could I check my answers and make sure that they were correct? Yeah, you could, guys. Here's what I'm going to say, though. This one right here that you rounded off, you're not going to quite get 0. You get close enough where you can say, yeah, I'm right, or whoa, I must be off. Okay? But it's not going to be exactly 0. Or you could just use the original answer and plug it back up in there. Y'all know how to do that on your calculator? Okay? You could do that, and then you would get 0. All right, anybody got a question? Everybody okay? All right, so I wanted to work one, we did these yesterday. So, oh, here it is. I want to work this problem right here for you. This is example 9. All right, it looks like this. ln of x minus 2 plus ln of 2x minus 3 is equal to 2 ln of x. Okay, tell me what you want to do. Subtract this one and bring it over here. I can do that before I make the fraction. I think it's probably going to make it more difficult. Oh, okay. Because here's what Jessica's thinking. When they add, what are you really going to do with your LNs? Multiply them. So it's really just like ln of x minus 2 times 2x minus 3. Do y'all agree with that? What am I going to do with this 2? There you go. So this is like ln of x squared. Now, here's the way I want you to think about it, okay? If you have ln of this is equal to ln of that, what do you know about this and that? They're equal to each other. Yeah, they cancel, those ln's cancel out, okay? Hang on just a second, my pen stopped. Oh, thank you, darling. Thought maybe I can make it, but I can't. Alright. Okay, so now we're going to have, let's multiply this out. Tell me what you get when you multiply that out. Uh-huh. Perfect. Good. Equals x squared. Now, it's a quadratic. How do you solve a quadratic? What do you have to do to it first? Yeah, you got to set it equal to 0, guys. And then I'm going to try and factor it because it's going to be faster. But you could use the quadratic formula. And, of course, if it won't factor, you'll have to. All right, so now I get x squared minus 7x plus 6 equals 0. Does it factor? Yeah. X and x, plus sign means they'll both be with the first one. Factors of 6 that had to be 7, 6 and 1. Okay? Now, look, I want you to be really careful on this. That thing is so tricky. As soon as I stand up, it comes back. Okay, so on this one, what's my answer? What's this one? 1. Now, you better check them because logarithms have restrictions. Can you take the log of a negative number? You can't. So what you're looking for is something that makes a negative right here where you have to take the log of a negative. He's going to be an extraneous solution. Okay? Now, will I know that if I put it in my calculator and check it? Yeah, because what's your calculator going to say? Error. He's going to say you have an error. All right? So, but I'm going to do it without a calculator. 6 minus 2 is 4, so he's okay. 2 times 6 is 12, minus 3 is 9. That one's okay. Let's look at this 1. What's 1 minus 2? He's extraneous. All right? So 6 ends up being my only solution. Okay? So look, this is what I'm warning you about. When you're solving these equations like this, always be careful and make sure that you don't have an extraneous solution. If you're checking solutions like you should be, you ought to catch it. Okay? Mm-hmm. How to get what? This x squared? I subtracted this x squared from both sides to set it equal to 0. Okay? Oh, it's the only, yeah, if the only solution that you get is extraneous and he won't check out, then, now listen to me. Just because it doesn't check, does that mean it's extraneous? What could it be? Wrong. Guess what? Wrong answers won't check either. Okay, but they're not extraneous. The definition of an extraneous solution is a correct solution that does not check. Okay, so the first thing that happens to me when mine don't check is I either look for something crazy that happened, like these negatives, all right, or, oh my word, did I make a mistake? Okay, so, Joe? Look, if you have ln of this, remember how we did one like this? If ln of x is equal to ln of y, then what do you know about x and y? There you go. And that's the property that I teach. The book does it a little bit different way, but I think this is the easiest way.
So what if does it not work if you have if it's like 20 minus 20 is 0, so log base something is 0, will that not work either?
That won't work either. And think about why. Let's say log base anything of 0. What, now first of all, this base down here can't be a 0, okay? But what can I raise to a power and get 0?
Oh, okay. So would that be extraneous then?
Uh-huh. He doesn't work. All right. Okay, so let's try this problem. This is example 12, all right? In this problem, we're going to deposit $500 in an account that is going to earn 6.75% interest. People, are you going to go to the bank and get 6.75%? Y'all, you're not going to get 2%, okay? It's going to be compounded continuously. How long to double your money? All right, so let's think about what's happening. We just solved exponentials and logarithmic equations, right? So now, here's what they're going to do. They're going to give you some real-life problems, and guess what they're going to be? Exponentials and logarithmic, all right? And you're going to have to solve them. They're going to be a little bit harder because they're not going to be nice, pretty numbers like 4s and 6s. They're going to be 2.793 and negative 42.89. You see what I'm saying? It's going to be a lot messier numbers, but y'all, it's the same process. It's the same process. Gallon.
I don't know if you told this, but you know the typo on the worksheet has supposed to be an N, not an R.
No, I didn't know that.
How did I thought you told her?
No, I didn't tell her. She probably just figured it out. So what?
The second page on the front.
Oh, it should be at the end. Yeah. I should correct that on my worksheet. Wow, I keep doing that. Oh my word, that other class, they'll go berserk. They won't. They'll never finish. All right. Yeah, on the second page of that worksheet y'all got yesterday, that has 25 problems. But the one today, I think it just has 8 problems on it. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this one just has 8. And it has the formulas on the top too.
So on the test you have the formulas on the top?
You're not going to have the formulas on the test. Not those 2 formulas. Okay? You won't have those. We did them last year. You ought to be okay with them. Remember last year, I put them on the board for you, and I said next year you won't get them. Okay? So, they're not, and, you know, I don't know. Who knows? Sometimes they're buried somewhere in a test, right? If I can't quite remember one, I'm looking through the test to make sure it didn't, like, come up in a problem. Okay, so how long to double your money? So, compounding continuously. Tell me what my formula is. Very good. A equals PERC, PERC formula. All right? So what's my principal? 500 times E raised, what's your rate? 0.0675. Got to move that decimal point 2 places to the left. Times what's my time? T. We don't know what it is. What's A? 1,000. Okay. So, y'all, this is the same thing that we were doing with nice, pretty numbers, all right? So, is it logarithmic? These are the questions I'm going to ask every time. Is it logarithmic or exponential? Exponential. People, if it's a log, it's not going to sneak up on you. It's going to have log or ln in it, all right? So, I'm going to box in the power. Okay? That's what I'm trying to get by itself. The most common mistake is kids are going to multiply 500 times E, and you can't do that, okay? So tell me what to do. So now, what am I going to get? 2. 2. You're kidding me. 2. So what? If they had said you're going to triple your money, I could have just put a 3 right there. That's crazy. You could do that, right? Does everybody understand that? But you don't have to. I mean, you're going to get it, so it's not a big deal. But some kids will recognize that. Okay, so now I've isolated the power. So now what am I going to do? Change it into a log. So I'm going to write what? ln of what? 2 is equal to, perfect. And now what am I going to do? So T is equal to ln of 2. Be sure and close that parentheses, guys. All right, how long does it take you? So 10.27. I'm going to call it 10.27 years. Takes you 10 years to double your money. Okay? Y'all, that's a long time to double, isn't it? Okay? Look, let me tell you something. Did we talk about retirement? Okay? How do we want our retirement to grow? Exponentially. Okay? So, over here, little money, guess what little money makes? No. Little money makes little money. Okay? And big money makes big money. Okay? Big money, that's why you've heard that old saying. The rich get richer and the poor don't. Right? Because we don't have big money to invest. Alright? Like the big wigs, Bill Gates, he got big money to invest. He invests his big money and he makes more big money. Alright? So we're not doing that. That's why you want to start saving for your retirement when you first start working. Don't be waiting until you're 45 and you got $4,000 in your retirement fund. You're going to be working for a long time. You better have $400,000 in your retirement fund. Okay? Alright. Here's another one. Example 13. Okay, I'm going to read this one to you. It says, from the selected from selected years from 1980 to 2000. The average salary, okay, all the kids made fun of me the way I say that. Yeah, I didn't know. I said, no, it's not celery, it's salary. And then they've all made a joke out of it. So y'all don't evidently say it like that, but whatever. Yeah, but I don't say that. In thousands is given by this equation. Y is equal to negative 39.2 plus 23.64 ln of t. Obviously, t has a restriction from 10 to 30. Now, this is a crazy thing right here, okay? Yeah, that's what you go, 10 to 30. And here's why. Because t equals 10 corresponds to 1980. Now, that's crazy, isn't it? What are they doing right there? They're testing you to see if you know what to do. You know, not just can you find an answer, but can you apply that answer and give me what I want to know. Here's what I want to know. In what year did the salary reach $40,000? Okay? In what year? Got a lot of little quirky things in this problem. Reach. All right, $40,000. Do public school teachers make a lot of money? Depends on where you are. Depends on where you are. There's some school districts outside of Houston. I'm not talking inside of Houston. I'm talking outside of Houston. They start at 51. That's pretty good, people. That's not bad at all. Okay? Guess what? They don't hire a lot of new teachers because they don't have to, right? They got a big pool they're pulling from. But depending on what you teach, you know, I have something. That's not bad. All right, so here we go. We're going to be, in what year? We're obviously going to be solving for that t. What's y going to be? Very good. 40. Not 40,000 because it's in thousands. Negative 39.2 plus 23.64 ln of t. Now, see, are these problems hard? I don't know what happened first period. I think they were still asleep. All right, so what's the first thing I should do? Look, yeah, this is what you're trying to get by itself. So I'm going to add 39.2. What, the 40? Yeah. Is equal to 23.64 ln of t. Now what am I going to do? Divide. They multiplied by 23.64, so I'm going to divide. So ln of t is equal to what? 3.35? All right, now what do we do? Let's just rewrite that thing, right? It's a log. Rewrite it as an exponent. What's my base? What's my base? E. E. Why is it E? Because it's ln, people. If it's ln, it's always an E. Raised to the what power? There you go. Equals what answer? T. Okay? So, E raised to the 3.35. Tell me. 28.5. All right, so 28.5 years. Is that the answer to the question? Not. In what year?
Oh, sorry, yeah, 98.
98? How'd y'all do it?
10 months.
I don't know. What's like? Mm-mm. No, 1998 is right. I just want to know how you did it.
I already started.
Really, 18. Okay, so that's the way I did it too. All right, and then last period they told me they said, whoa, Miss Davis, why, that's so hard. Why would you do that? Because that's what I did. I said, oh my gosh, 1980 is 10, so I have to take the 10 off of here. So I'm really just adding the 18.5, and then I get the 1998.5, right? Well, guess what they did? They looked at that 28.5 and this 30, and they said, oh, I'm just 2 off. So they took 2 away from that 2000 and got 1998. I'm like, okay. Okay. So that's a pretty cool way to do it. I didn't think about that, but I thought it was a good way. Okay? All right, anybody got a question? Okay. So let's do another one. Now we're on the next section. This section's got some crazy looking problems. Okay? So we're in 3.5. Okay? Now here's what these problems are going to be. These problems are going to be like formulas you've never seen before that you're like, what in the world? So I'll show you a little trick that I can use sometimes if I get a little confused. So here's what it is. The ratio of carbon 14 to carbon 12. Do y'all know what we use carbon 14 and carbon 12 for? Carbon dating. Yeah, carbon dating. Dating like we're going to dinner tonight? No. Yeah, like how old are you? All right? So they probably don't use a lot of, hey, guys. They probably don't use a lot of carbon dating on us because we're not very old, right? But what if we found, it is a 13, what if we found a bone in the backyard? It might be a dinosaur bone, right? If it was really big. And we would use some carbon dating on it, okay? So they tell us that the ratio of carbon 14 to carbon 12 in a newly discovered fossil is 1 over 10 to the 13th. And then they give us this crazy formula that looks like this. 1 over 10 to the 12th times E raised to the, oh, we haven't even gotten there, y'all. This is crazy. E raised to the, no, this one's not as bad. Negative T over 8,267. That's equal to R. Okay? And so they want to know how old's the fossil. So what's the first thing I have to do? Yeah, you got to plug in that right there. So now I'm going to say 1 over 10 to the 12th times e to the negative t over 8267 is equal to 1 over 10 to the 13th. Now, remember, if you get confused or something, then you just stop and you go, whoa, wait. I just need to know, is this a logarithmic or an exponential? Okay, so find the power and put a box around it. Now, how do I get rid of 1 over 10 to the 12th? You can divide by 1 over the 10 to the 12th, or you could what? Multiply by what? 10 to the 12th. Okay, so I'm going to do that. But y'all listen, you have a calculator. Okay, so it will let you do that. These cancel, and you're left with e to the negative t over 8267 is equal to, how many 10s can I cancel? 12 gone, 12 gone, you're left with 1. That's 1/10. That's 0.1. Now, can I rewrite it? All right, what do I say? Ln. Why Ln? It's the base of e. Ln of what? 0.1. The answer is equal to negative t over 8267. I'm going to let you finish working it, and here's what I want you to do. Because this messed some kids up on the last test. I want you to do that. Okay?
Those things can be changed to a quantity.
Yeah. So first you multiplied by 8267, right? You got a negative, and then you divided by a negative or changed both the signs. Tell me what the year is. How old is it? 19,000 years old. Slightly. No, I didn't say thousandths, so be careful. So, I'm slightly older than me. All right, wait, I got to give you a worksheet.